Hi everyone. Good morning or good afternoon. Thank you so much for joining us here today. We're hosting a special guest webinar. My name is Tracy Berardi. I'm Program Manager of the Cloud Standards Customer Council. Today we're going to explore OASIS TOSCA. TOSCA is a standard language used to describe a topology of cloud-based web services, their components, relationships, and the processes that manage them. We're going to cover key concepts, benefits, open source tooling support, and some plans for the future. So I'd like to welcome our guest speaker, Matt Rakowski. Matt is chair of the TOSCA Simple Profile Working Group, co-chair of the TOSCA Interoperability Subcommittee, and a senior engineer at IBM working on open technologies. If you'd like to download the presentation file, we've added a link. It's in the chat box in the GoToWebinar toolbar. We'll also be recording the presentation. So later this afternoon, if you go to our website, the events calendar, you'll also find a link to our YouTube channel where we'll post the recording. We should have some time for Q&A at the end of the presentation. You can pose a question at any time through the questions box in the toolbar. And with that brief introduction, I'll turn it over to you, Matt. Thanks for joining us today.
Thanks, Tracy. So everyone here gets to see the new TOSCA logo. I think it's the first presentation that we have this on. I'm hoping to, for those of you who have seen or heard about TOSCA over the past few years, to give you something new. And for those new to TOSCA, really try to distill some interesting points why it makes it interesting to use for orchestration. Next slide, please. The agenda is fairly straightforward. We're going to cover what is TOSCA to level set everybody. We're going to go through what makes TOSCA unique. So if there's some new thoughts there, we're going to cover key modeling concepts when we're asked to try and distinguish what makes TOSCA special. These are the things that we always point to, these key things, and I'll show you why they're important. We're going to talk about the growing ecosystem grounded in reference in other standards and open source, and we're going to cover what's next for the future. Next slide, please. What is TOSCA? An important open standard, important of course, because we're talking about it today, that is enabling a new unique ecosystem. What we have is a domain-specific language that allows you to declaratively describe your applications or your topologies or your platforms or infrastructures with key entity types like components that are related to each other through relationship types, that different components declare their requirements for other components' capabilities. You can include configurations for those components that are used for installation or update. You can attach policies to different parts of your application as well to govern how those things are deployed and managed over time. Key aspect of TOSCA, one of the tenets that we always worked with is portability. Our goal is to achieve automation of an application in a cloud space. That's our primary goal, and eventually to manage it over time through its entire life cycle. The portability aspect allows people to you have a choice in who they deploy applications to. With the tooling that we provide in open source and other places, you can target different clouds with the same models for your applications and achieve the same end results for your deployment, scalability, and things like that, and reliability. And the hope is to reduce costs, that you can model applications once, you understand completely how they're supposed to be governed through their capabilities and configured, and you clearly understand how which policies are intended to be conveyed to the receiver, the cloud provider, that need to be enforced from different installation to different installation. So next slide, please. So this is a slide that's meant to impress with, hopefully you'll see your favorite logoed company on the right. But fundamentally, TOSCA has been around for a while. We published our first version of TOSCA back in November 2013, finalized it. It was an XML format. And when we went to take it to the cloud space, they said, well, we're not really big on XML, so how about doing something more cool and modern? So we actually shifted course, and we created what's called the simple profile, which is a YAML format. We've had 5 public drafts over its evolution since probably early 2014, and we finally published, after two major public review drafts, one 60-day, one 30-day, we have the final one out, and we hope to move to be an official OASIS standard by end of year, which will be an OASIS-wide vote, and then 1.0 will be in the books as a final standard. 1.1 is coming along. We'll talk about that at the end. We have some significant additions to the TOSCA family. We encourage domain-specific profiles to be authored that derive from the base specification. And one of the ones that has gotten a lot of attention lately is the network function virtualization profile, which tells how operators, providers of clouds, how they can follow ETSI standards to deploy virtual network functions to create things in their infrastructure. We'll talk a little about that later as well. Again, we have lots of participants in OASIS. OASIS is a very good standards body to work with, and they have a great staff. But in TOSCA itself, we're like one of the largest committees, our working groups, TCs in OASIS, and our active participation is quite impressive. In fact, you'll see with the number of working groups that we have going that we have a lot of good active participants looking at TOSCA from different angles to try and make it more and more usable now that the core specification has been completed. I'll call out the fact that in alignment with the NFV profile work, one of our new liaisons is the ETSI NFV liaison. So we're working with various groups at ETSI to make sure that the TOSCA specification and the open source and all things we're creating is used and adopted by other parts of the ETSI networking specifications. We've continually demonstrated interoperability from the XML days of 2013 at EuroCloud to most recently at OpenStack Summit, where we actually showed interoperability of TOSCA using OpenStack as the platform and other platforms as well in Europe for working with CERN on the Indigo Data Cloud project. So every year we try to have a major interoper event, and I think that we can't get much bigger than working with multiple countries and many different research centers and universities across Europe than we did with CERN this past year. Next slide. So I don't know if some of the slides are getting cut off in the bottom from my perspective, Trace. I don't know if that can be correct or not. But
oh, I'm sorry. It looks okay to me. Let me just check the view. I'll take a look, but you can keep going. Yeah.
Okay. All right, so I'll keep going. So here's an interesting concept. So when we started engaging ETSI, we were asked, okay, TOSCA, are you an information model or are you a data model? And we actually said, well, we're neither really. We're kind of like an information model, but we actually have data model characteristics and we carry data models. But we really do a lot more. And so basically we thought hard and basically call ourselves an intent model, which means that what you do is you give us a template and all of the requirements you need for deploying your application, and you describe what you want it to look like in its steady state, and and you give us enough information to maintain it in its proper steady operational state. So we take the best of the data models. We actually are compatible with data models there. We don't compete, which people have often said. We can carry JSON data and Yang data. We actually can model data in TOSCA as well. We can create complex data types. We have constraints and validation semantics. But we also have topologies that are grounded in a very small but concrete meta model. We also have a concept which was introduced in TOSCA. This is unique. We have the concepts of requirements and capabilities, which one component can say, I have these requirements. Another component can say, I have these capabilities, and orchestrators can match them together. And lifecycle is very important. Most models don't consider states through a course of a lifecycle. They get you to a state and they're done. We actually try to make sure that we can cycle you through different states, and we have normative lifecycle state representations and state transition graphs and things like that in our document that orchestrators can follow and maintain, and they can be extended. And a cool thing is policy. operational policies are our focus. We don't do security policies. But these are things that we bring to a model that really focus on how to model deployments. And I should point out that we actually support imperative logic and workflows, which we'll talk about at the end as well. So we can do things declaratively. We have plug-in points for imperative logic to do state transitions if you want to use that. But we also can actually do imperative workflows to take over more complex tasks. So we're actually compatible with popular scripting tools like Ansible, orchestration things like Bash and Chef and Ant tools and things like that. So cool stuff. Next slide, please.
Hey Matt, it's Tracy. I was just playing with the screen to see if I could sort of zoom out a little bit, and I couldn't get it to work. But I was thinking, you're smarter than me. Do you know a little trick maybe that I could zoom out a little bit?
Well, I think that, well, my intelligence is equal to yours in terms of use of GoToWebinar.
Oh, I wasn't sure if there's something on my own, laptop somehow, because I am displaying my screen.
Well, usually at the bottom, the slides are downloadable by people at their home or office. And
okay, I'm sorry, everybody.
Usually the last slide is the last statement at the bottom, usually some flavor text. Hopefully I'll remember to add flavor to the slides as they go along. Next slide, please. Okay, key modeling concepts. This is to keep me on, these slides are keep me on track. So the first part is topology. Next slide, please. So here are the fundamentals of building a topology. So it all starts with nodes and relationships. So the basic stuff you would expect typically in an information model. But we actually treat relationships as a first-class citizen, that they actually have direction in terms of dependencies. So in this diagram, node A connects to B, so there's a direction to it. A depends on B. We can actually reverse the direction or make them codependent on each other directionally. And they are connected, they can be typed on both ends. So we can actually figure out if A can actually connect to B through the requirements and capabilities if the types match on both sides. In addition, we can restrict, type A can actually restrict what types of or subclasses of type B it can connect to as well. So let's say node A wants to type, is a web application, wants to talk to type B, a database. It can have a general connection type to say I want to connect to a database, or it can actually limit itself and say I want to connect to a specific type of database like a NoSQL database or actually a named database like CouchDB. So these are the types of things you can do with fundamental topology creation, modeling in TOSCA. And I threw in a group here too, so you can actually draw a logical circle around a group of nodes, so you can actually manage them together or apply policies to a group of nodes. So if if these things are to be placed together, for example, you can group them and say, here's my placement policy for this group of nodes. So basic concept for TOSCA. Next slide. So fundamental to TOSCA is we think of two things in terms of defining relationships. We think of principally containment and connectivity. So in terms, and what we see here is we've taken the previous slides, the application database tier as I described them, and we've shown how we build up through containment principles both the application database tier. We have a logical container, a tier, which might be a group, and inside of it I have a web server. It's contained inside of it. I think I lost the slides shut down. I know you're trying to play with them a little bit. Yeah, so yeah, I think the slides are kind of in are framed for widescreen. I think that's the problem. So if there's a
Sorry, I won't play with it anymore. I just tried one more thing, but I'm done. Sorry about that, Matt.
That's okay. So inside the web server, that's a container which can contain web applications, one or more, and also perhaps also contain libraries or modules or packages like a PHP module. And the same thing for database. We have a logical database tier which can contain a database server, as well as the database itself, and they're all modeled in TOSCA through containment relationship called hosted on. And then different tiers can actually connect together, and this usually implies some communication channel. So we can actually do parallelism with this. So we can actually see we have two logical tiers that actually can be deployed or orchestrated in a parallel fashion because this relationship exists for connectivity. And because of the direction, we know that the database tier has to reach a certain state of deployment before we can actually connect the application to tier 2. It depends on it. We know exactly which component based upon the TOSCA topology where these dependencies exist. Okay, so next slide, please. Composition, next slide. So some aspects of TOSCA that are often lost when you just set about writing some simple deployment models is that we can actually do some interesting things with composition. So I mentioned the connectivity concept. So if I have my associated application database tier, my apologies, if you have those two tiers on the left already existing, we can actually go out to perhaps a catalog of these topologies of service templates that you created in TOSCA, and I can find this a monitoring tier, and I can actually I can have my application tier already waiting to actually send some monitoring service, some information through collecting our syslog, and I can actually find a service template that exports a capability of receiving logs and data through these mechanisms, and I can attach it to my model. So I can compose service templates together and connect them through these connectivity relationships at a service template level. And we did exactly this. So a year ago at OSCON 2015 July, not quite a year, we actually had a number of companies demonstrate a TOSCA topology running on different clouds doing exactly this. We actually stood up, everyone stood up these three tiers from separate service templates. So we showed interoperability against exactly this type of model. Next slide. There we go. We're getting to the bottom now. Oh, I lied. It disappeared. So this is something that's new that you have seen before. I created this yesterday. So one important thing that's lost in TOSCA is that you can do abstract substitution. So you can actually compose templates that are valid that have abstract nodes. So on the left, I might have a service template that has my web application. It can definitely be standalone, but it has this abstract requirement for some monitoring service to be named later. So what I can do when I orchestrate this, or either at deploy time, runtime, or I can actually do this at design time if I wanted to. I can go out to a catalog or look for my existing data monitoring services in my current cloud, and I can look at the requirements of the application and connect it to or install or find one in a catalog and install a monitoring service that matches those requirements. So I can actually substitute this abstract node in the application for monitoring with a concrete implementation either running in my cloud or one I install at runtime, deploy time from a catalog that provides that function. And it goes on and on. That monitoring service could in turn have some analytic component which I could go out and search for that's already running in my cloud, or go back to my catalog and find an analytic service in TOSCA to deploy. So I can actually do this composition, and this becomes very important when you try to layer topologies. TOSCA we describe fundamentally for how to do cloud applications because that's the majority of our users. But for those actually hosting clouds or hosting cloud environments, they often have multiple tiers or layers. I might have a PaaS layer, an IaaS infrastructure layer, but below that they have physical layers. All these things can be modeled in TOSCA, and at each level you can make each layer make that an abstract layer that can be viewed from the layer above it as an abstract set of node and capabilities, and the actual implementation can be hidden in a different service template or described elsewhere. So this layering is very important. In fact, I know of companies who have modeled their complete cloud networks and infrastructure up to 7 or 8 layers using TOSCA. So next slide, please. Portability. Next slide. So another new slide. So what makes TOSCA portable? So basically our method for capturing topologies, all these meta-model constructs, the policies, groups, and relationships, and even the artifacts, the installs, the scripts, or the imperative logic, or the actual deployment artifacts, that maybe the tar files, whatever you use, we can actually package those into the service template itself, and it's what's called an archive file, and put that into a catalog and store it away. Or we can actually, in the service template, reference those artifacts or reference things in other places or databases or catalogs as well. So I can have a service template that actually points to a policy that's stored in a policy catalog. I can point to a tar file that's maybe stored on some catalog distribution site saying here's the approved tar file for installing some version of some software. Here's a library package that I want to grab from the web. I can point to those things and define repos and add credentials and things to tell the service template where to grab these things from as well. So these things are packageable and translatable you can pass them from company to company, share them around, etc., and compose them as we described. The TOSCA meta model is very concise in trying to limit the number of meta model entities we have. Nodes and relationships, again, are fundamental. They have capabilities and requirements, but they also have properties and attributes, which I won't go into too much here because basically they're inputs and outputs. So the nodes and relationships, you can actually set properties or the inputs, saying here are my settings, my configurations, and after they're running or deployed in the cloud, you get the outputs or the attributes. What's my current state? And those we're making queryable and actually monitorable in the future through future workgroup efforts. And you'll see that at the end of this discussion. Groups and policies are there as well, so we sprinkled on our groups and policies to help better manage these nodes and relationships. But they're grounded in normative types. So the core spec, our focus again was to make sure you could deploy applications in the cloud. And that was our focus. So we actually have normative types that describe things like compute nodes, virtual machines, containers, and databases, web servers. We have a small set of normative types that when you write applications, that no matter where you go in TOSCA, if the provider has a TOSCA orchestrator, they understand what these nodes are. So abstraction is possible, substitution is these things are possible. You can actually be very precise when you actually, like I mentioned before, you can actually say I want specific databases. You don't have to use abstraction. I can say I want to use exactly this tar file for this database, this exact version. Here's my detailed configurations. Or you can actually tell the TOSCA saying here are the basic required properties for a database. I just need my user ID and password, maybe a certificate or something, and give it a port number. I'm off to go. Let the cloud provider make intelligent defaults. So we actually have normative types that try to reduce the number of configuration parameters or properties that are needed to set up each component. You can extend those node types to add all the properties, all the configurations you want, but we encourage people in modeling with TOSCA just to provide just what you need to get going. We want to reduce the complexity, again, trying to achieve portability. Next slide, please. So we'll talk about having the requirements and capabilities. That's key. So in the application, I got my service template at the top, and my service template resolves a lot of its dependencies inside of itself and its topology, but in the end, it has some abstract requirements. It has perhaps some compute, network, and storage requirements that my provider expected to give me because they're providing IaaS resources. There might be other externalized requirements as well, and that's represented by the down orange little chevron arrow thing. And I take that and give it to my orchestrator and TOSCA, the cloud provider, and he rocks that topology and says, I have these missing requirements. I need to fulfill them with what's in my infrastructure. So he looks at those things and figures out perhaps what the best infrastructure to create or place you on based upon those requirements and additionally policies, but also makes you portable. So that orchestration, that matching can be done regardless of the underlying real networks, the real storage, or whatever virtual machines or hypervisor technologies are being used in a cloud provider. That's what A, B, and C at the bottom trying to show is that those are different networks, perhaps different processor chip types, different storage types, and they're maybe laid out differently physically, but you don't care in terms of the orchestrator is going to figure that out for the target platform, for the target cloud provider, making it portable. Next slide, please. Lifecycle. Next slide. So TOSCA nodes and relations both have life cycles, and this talks about the nature of being an intent model state. We try to get your application to the correct state, and we can cycle nodes through different state transitions to achieve basically deployment and undeployment in general terms. And as you connect two nodes together, maybe there's dependencies, a source target dependency or a codependency between two nodes, we can actually declare additional steps or configuration steps that configure both ends of the relationship relative to their deployments. So we can actually fine-tune how A and B might exchange information. So this helps because A doesn't necessarily need to know about B or B about A. Your relationship brings extra logic into the picture that allows you to bring two disparate nodes that might have very complex configurations together by adding an intelligent relationship. Additionally, we allow you to subclass lifecycle and add your own operations if you want to. They won't be normative, but you can declare them in a way where we know they're supposed to exist in relationship to the standard lifecycle. And we actually are advantaging this in our workflow work in version 1.1, which we'll hopefully have another webinar on in the future, because workflow is a very interesting topic, so it allows us to do complex things relative to state transitions and actually have take over complex installation configurations relative to these state operations. Next slide, please. So I think, basically this is similar to the last slide, but I wanted to point out that it's all about state. That when we actually have a complex topology, it's important for us to know which node is in what state at what time. So if things go wrong, we know how to back it out or how to pause it. And we know how to disconnect through a connection relationship one node from another so that we can maybe switch it to something that's working. So let's say our database goes down, or maybe that's a bad example because you'll probably have data in it. But let's say you have a logging service go down or an analytics service go down or something to that nature. And you can recognize I can stop that connection. I can pause a node, and I can actually reconnect it and turn it back on and point it to a new service that fulfills has the same capabilities, fulfills the requirements of another node, so it can keep running. So these state transition and lifecycle events are very important and fundamental to TOSCA and allows you to do management. In fact, we have a working group working on a instance model where you can actually get snapshots of your current topology as it scales, or your application may change over time, and capture the current states, and actually perhaps even create an API to interact with the model and its states. So very interesting. Next slide, please. Policy. Next slide. So policies are basically what we call non-functional requirements. See, these are requirements that affect some behavior of your nodes while it's being deployed or in its steady state operational state. Again, we don't focus in TOSCA on security policies. We very clearly say we're doing operational policies, things that we can point to in the topology. So things that affect deployment, things that affect operations. Things like placement. We can control where nodes get placed on different compute nodes, where data gets placed on different storage targets. We can group nodes and say these things must be placed together or co-located. These things must be anti-located and anti-affinity. We describe how things can scale together, both at a node level or at a group level. These things we do cover in TOSCA, and the groundwork for these things are in version 1.0, and we're actually adding some polishing touches and extending some concepts for policy in version 1.1. As you can see here, you have granularity choices. In TOSCA, you can actually attach policies to lifecycle, so you can actually cause actions to occur when certain state transitions happen, when these operations are, before these operations are invoked. You can actually attach policies to nodes themselves. So anything that happens to you can actually affect a policy for. So you can actually do pre-deployment actions. And you can actually group nodes. As scaling is one of the placement and scaling is very popular, saying these things need to be placed together or scaled together as a group, and I attach a scaling policy to a group of nodes. So you have a choice of granularity where you place these policies, and if you have a policy engine alongside your orchestrator that works with the orchestrator, you can achieve these policies. You can affect these policies, I should say. Next slide, please. So we have a model for policies, an event condition action model. If anybody has ever worked in policy work, whether it be security or otherwise, this model comes at you quite often, and I'm sorry for throwing code up here, but we're very proud of this work that we basically we're looking towards a very small set of event types in TOSCA around deployment state changes, and we'll define those, and we're going to have events that describe those state changes as well in terms of placement, scaling, etc. And you'll be able to declare the filter. Basically, you can actually create a policy standalone and say this policy can apply to these types of nodes. So you can actually restrict where policies are attached to based upon this filter. And you can describe the condition by which this policy action is triggered. So basically, you can say I want to attach to this node, and I want to look at this requirement or capability of the node, and if this condition or state exists in the node down to an attribute, I can look at an attribute of a node saying if your CPU utilization or your memory consumption or some attribute the node exports has this test be true, then I can perform the action associated with this trigger. And I can actually have some script triggered, I can invoke a service, etc. So these are the things we're adding to TOSCA, and we're filling out these descriptions in version 1.1. Next slide, please. Where we're referenced. Next slide. So TOSCA is taking off in many areas. I'm not sure where all it's used. I have knowledge where people have come up and told me from large companies, especially cloud providers, they use TOSCA inside their cloud. Even though they might not have a TOSCA orchestrator and support it for their applications, they actually model their networks. They model their storage. They model their platforms in TOSCA, often with their own tooling. But we like when tooling is open source and public so everyone can benefit. I give great credit to Gigaspace and Cloudify. They've been a big proponent of TOSCA and helped evolve with us from XML to YAML. And they've done some amazing things. In fact, this past March at Mobile World Congress, they announced the Aria project, which is basically they've taken the majority of their already open source Cloudify work, and they've taken some of their internals that actually can take TOSCA models and actually deploy to multiple clouds, such as Amazon, Azure, VMware clouds, and OpenStack clouds. And that's all open source, and you can actually have your developers submit pull requests and make changes to the code or suggest changes, and it's a beautiful thing that this TOSCA orchestrator that can deploy to multiple clouds is out there for anybody to consume. It doesn't have UIs and editors and things. That's what you get from Cloudify, and you get a lot of extra things from Cloudify. But Aria is there, and you can leverage that if you're a provider. Alien for Cloud is a type designer, workflow designer that works with Aria, that works with and Cloudify. So some reps from Alien for Cloud, Fast Connect is behind it. They are strong participants in the TOSCA working groups, and they're actually working on their workflow description in version 1.1. So if you want some graphical tools for type design in TOSCA and workflow design, Alien for Cloud is a great place to start. Research groups and standards groups in orange. C Clouds has done a lot of research in many universities across Europe, different languages. I can't read all the papers, unfortunately, because I can't read all the languages, but there's been a lot of studies done on TOSCA, how it can be applied to different domains. And I mentioned before, it's been designed for cloud and cloud applications, but it can be used for anything. A little aside, in fact, I was having a conversation just the last couple days about what's a good analogy for where TOSCA could be used, and I kept thinking of the I'll date myself, the Apollo-Soyuz space mission. Maybe I'll just use the space station analogy where people want to add an inflatable habitat, and these are being designed in 2 different countries. So with TOSCA, you could actually model the space station as having a docking, its capabilities of having a docking ring, and with certain requirements for how do you connect to it. In a whole different country, as long as you model the requirements and capabilities, you could care less. You could actually model the entire space station in English and a whole bunch of other languages, and all the details of the insides of the space station. But the docking ring, you are very particular, and somebody else can come along from another country and create their model for their attachable module, habitat or whatever, that wants to connect to the space station. And as long as they match the capabilities and requirements exported by the space station, they could design their whole thing in their own way with their own model, with their own configurations in their own language, and they can still connect where it counts. And that's what you do with TOSCA with nodes. You declare just the configurations and the connection points, the requirements, and the types and things that matter, where you connect the components together. So cool stuff. In fact, we've been asked to write 1 or more IEEE papers, which we'll be talking about intent model and some of these concepts in a better manner than I did just now. So look for those coming up. Indigo is part of the CERN project. Everyone hopefully here is a fan of CERN and all the cool things they're doing with the Super Collider and all the discoveries they're making. Well, Indigo is part of that effort. They actually, as I mentioned before, demonstrated OpenStack Summit in April in Austin. We actually disclosed our demonstration where we had across Europe in many different countries and universities. We actually used TOSCA and OpenStack, in some cases not OpenStack, but used TOSCA models to deploy both data and applications to different universities' infrastructure, cloud infrastructure. Disparate architectures, disparate compute models, but basically it allows number crunching and large MapReduce big data type things to be done across clouds in different geographies using the same models with guaranteed validatable results. That's achieved through TOSCA. Open interfeed parser, so that one of the big use cases for TOSCA are cloud providers, and a lot of this work you might not see unless you're a provider or into networking. But TOSCA I view as the standard for NFV modeling. And TOSCA can work with other data model centers like Yang. You can have Yang descriptors of your networks and things deep down, and those can be part of your TOSCA models. And at the top level, you can actually show how your networks and things can attach to create network services that applications can actually connect to from your mobile phone or IoT devices or whatever, sensor devices. These things can all be modeled from the top down. If you look at the backup slide, I show a hint of a pictographic view of how that's being done at many layers. OpenStack, no secret that we're big in OpenStack. We have the heat translator, which IBM leads. We actually try to create we actually have a parser translator that can, for OpenStack, translates to what's called a hot language to be used by their native orchestrator. But the actual translator code itself can translate to any language. In fact, we did an exercise where we tried to actually translate to Kubernetes and Docker with Kubernetes descriptor with using Docker containers, and we can actually do pluggable replacements. So we can actually translate to IIS or translate to like a Kubernetes Docker container type output as well. So we can actually, even though it's called heat translator, it can translate to more than just heat. Tacker is the project in OpenStack that does NFV. If you want to orchestrate network functions, virtual network functions, Tacker is the project, and it takes TOSCA models exclusively. And so they're implementing one of our profile specs to do this, and they're actually helping us evolve that profile spec to make sure it has all the things needed in it to describe your virtual network functions. Next slide, please. So just to dig in, if you're curious about OpenStack, it's like I said, we're taking off. The parser and translator are in the middle here. Tacker, again, we just talked about up in the top. OpenFE parser is supposed to work with OpenStack as one of its target environments. It's an open source project that it works with our parser. Cinlin is a clustering and policy project, so all the things I talked about in policy. We have blueprints already open. TOSCA has been approved as the standard they want to move to use as their inputs to accept for policy format and for describe clusters of application containers. And they need some help. They need some, if you're inclined to do development work and you like Python, and that's a good place to contribute. The blueprints are ready to go, designs are ready to go. Just need somebody to do the work. Cataloging, I mentioned grabbing TOSCA templates from catalogs. That's exactly what we do in OpenStack. We have 2 catalogs. One's called Murano, which basically, and it's not uncommon in OpenStack to have different projects do similar things. We also have the Community Application Catalog, which is new. This last release, we announced it in April. So we have 2 catalogs where you can actually insert your TOSCA models, make them available. In Murano, you can do some more things. You can attach pricing models and other things to it as well. Community App Catalog is basically more like standalone applications. It doesn't consider the business models and pricing and things like that, but Murano does. So we have 2 catalogs, or if you write TOSCA models and use OpenStack to deploy, you have a place to check them in and query them and find them and tag them for what they do and make them available internally or externally, whatever you want to do with them. And it shows what you can do with the Heat translator. So basically anything that the Heat project can do, we can actually interact with identity stores, image catalogs. We can actually work with the metering service. We can deploy databases. We work, of course, with compute network storage, and we work with any component in Heat. We could eventually create a TOSCA node type for that we can actually translate and make deployable in OpenStack. So next slide. Work group activities, cool stuff. Interoperability, big thing is conformance. In terms of commercial adoption, this is my #1 priority. We're working very hard. We're going to create a GitHub repo. We've decided to actually use TOSCA templates themselves to create use cases that test every part of the specification. And we have a tag format that we're going to put in TOSCA metadata in the service templates that actually is an OASIS standard. It's called test assertion. It's a markup standard, and that assertion markup is going to put in metadata in templates. So we can actually verify what the input to the test should be, what the behavior of the test should be, what the output should be, and we actually have discrete warnings or errors that we can emit if those tests fail. So you can actually, if somebody comes to you and says, I support TOSCA and I support version 1.0, you'll have a set of tests that they can run, and you can compare them to the expected outputs and to prove if they pass or not. Eventually, I'm hoping OASIS might be able to have some conformance accreditation of some type, but we'll see. But all these, we're actually composing right now. We have a set of maybe a dozen or 2 test cases already, and we're going to be filling out over the next few months. So I'm hoping to announce the GitHub repo is available, invite people to submit their own test cases, but our intent is to go through every point section of the spec and have a test for every piece of the grammar, every piece of the requirements that are listed, all the shells and shoulds and things in specifications will all be tested. But we welcome people to contribute and add their own tests where we may have missed some. Containers, we're working on clustering. We have a group construct which we've evolved. We want to finish clustering for 1.1. Instance model, lots of work to be done there. Because it's a very imposing task to actually try and a template going in is small and compact and neat, but when I grab a instance model topology that's been running and deployed for a year and it's spread out and scaled and be able to interact with it, that's a challenge. So they're working on describing the instance model and making it interactive through API commands and things like that. So very cool work being done there. Monitoring, very important. This is a closed loop. So how do we use policies to basically monitor for events to know that we have bad health or we need to scale, or performance is lagging. So we're going to be working on creating a small set of events that focus on health, scaling, and performance that match the policies, and basically stick to things like very high-level things like we talked about a red, yellow, green policy that should be green. So you're fine, you're green. You're yellow, you're kind of questionable. You might want to scale, or you might want to do a failover or something like that. Or red, something's going really wrong. Take some action now. So you can actually create rules in your policies against these monitored values and these events that would come back to you against your policies, and take your corrective actions that you've declared in your policies. Network functions, again, I've talked about this huge area. We've expanded the scope to include software-defined networks. We do some more advanced things, network things that you don't think we have. Actually, we do linkages. We can do low-level network-to-network links. We can actually do forwarding graphs. We can actually declare when data comes into a network what path it takes through the network. These things we can do in TOSCA, some very cool things that enable very low-level switch routing type descriptors and low-level linkages at the hardware level. So very cool things in TOSCA. Next slide. New features. So 1.1, I'm trying very hard in the next 2 weeks to take a vote on 1.1 to get a public draft out. I'm hoping to have it out in June, but I want to have the final 1.1 to be done in third quarter. The goal for me is to produce a point spec every 6 months. So 1.1 has taken a while because we had accepted a lot of use cases because the adoption has grown. Our use cases kept coming in. But from now on, I'd like to have very, very discrete small point releases every 6 months. Again, matched with test cases and conformance suites. The cool things for 1.1, metadata. Every entity in TOSCA has metadata, from a service template, a node, relationship, to a data type. You can add your own metadata, their key value pairs. And we're doing some cool things normatively in spec. Like I said, the test cases use this metadata at the service template level. Group types. We expanded group type to be, instead of a stupid grouping, a logical grouping, to something that can be used for management. We've extended it to be more like a node, which has lifecycle and things like that. So you can manage as a collective group anything that belongs to, any node that belongs to the group. Groups have members, those members can be managed together. And the group can exist and represent a logical group of things as things are being scaled or moved or failed over. So we've extended the group to be more of a management entity and less of a logical entity. Policy definition, you've seen what we're doing there. That work will be completed in 1.1. It has been completed. Workflow, we're almost there. That's the last thing I'm holding up 1.1 draft for. Clusters, we probably won't have in the first draft because we're still debating heterogeneous and homogeneous clusters. And that debate's going to take longer than I want, so we're going to do that probably between June and final in the third quarter. Next slide. Come join us, learn more. We're trying to engage you at many levels. We've got a wiki page, we've got, of course, our public TC page. Everything in OASIS, that means everything in TOSCA is public. Every email, every presentation, every interim draft, every meeting minute is all public. It's not be great. The search engine is not that great, but it's there, and I can help you find stuff if you need to find something. We publish on YouTube videos. We have a media, a technical marketing and education work group. They're working on adding more videos and sending out tweets and doing all sorts of things, writing blogs. Of course, our specifications speak for themselves if you're interested. And of course, if you want to participate, contact our co-chairs. That's it. Q&A. Any questions?
Thanks, Matt. I think I'll leave this slide up for a little bit. And I did want to let the audience know that we do have an updated version of this PowerPoint with an additional couple of slides, and we're going to refresh the link to the PDF on our site so you have those. So I'll go ahead and send it to everyone that was online today so you have the updated deck. Sorry about that. We made a little switcheroo. So we do have some questions, and if you'd like to enter some, you can do so now. First question, let's see. Matt, at one point you mentioned a space station example. Do you know if there's a published reference for that example?
No, I was ambitious in my mind and wanted to create one for today's presentation, but I ran out of time. But again, these are things that we will probably maybe not use that analogy, but you'll see in some IEEE papers we're going to start authoring soon.
Great, thanks. And Matt, when you were discussing the working group activities, there's a question here about interoperability. Do you think you should use portability rather than interoperability as you port the TOSCA descriptions to a new target system?
It's the intent, not always the name. So I think that one of the major emphasis for interoperability of work group is is portability, because we're validating and creating conformant tested test behaviors when cloud providers or tooling receive these normative types. So all the ingredients that go into portability are already baked into TOSCA for the most part. And if you have conformance tests that validate that they can handle the schema correctly and they can actually adhere to the normative types that we've created, or custom types that other people can import, that if those things are met, then you're 90% of the way to portability. We have best practices for portability. You know, not every TOSCA model is portable. I can actually attach imperative logic and data if I want to. I can be very prescriptive, and I can make sure it's not portable, but we encourage best practices to be non-portable. I don't know how you necessarily test for those things, other than publishing best practices. It's basically sticking to declarative, being non-specific and asking for certain types of components that might not be available at a target provider, and not adding imperative logic that might not work on a target system. The more you can do declaratively, the more portable. That's the general rule. If you want to join us, if you have thoughts in this area, we'd love to have you on the Interop subcommittee, and maybe we could even rename it. This just takes a vote.
Thanks. Matt, could you tell us a little bit more about the TOSCA and Kubernetes mapping software?
Well, it was an experiment we did about a year ago. One of my colleagues worked on the name escapes me, but it'll come back to me. On OpenStack, he worked on the project to do the Kubernetes service. And basically, he also understood TOSCA. He helped work on some of our translation software. So he basically said, well, let's make this pluggable. So over the last year, we said when we load our type systems in and our translations in to go from TOSCA to the hot language, we said, well, we could just as easily, if we have a topology that has containers, what we did is we created a container type called Docker, and created a management cluster type called Kubernetes. And basically, we loaded two plugins that would basically, if I had a model that had those types in, we loaded those translator plugins, and we converted to Kubernetes dialect. And we basically took those Docker nodes in our topology, and we turned them into the Docker references in the Kubernetes grammar, or whatever you want to call it. But we never really published it. We talked about it I think a year ago at OpenStack Summit after we did it, just as an exercise. But again, the Heat Translator and TOSCA Parser are public libraries, and anybody can contribute. We'd love to be able to, if we can translate to other target platforms, we'd love to be able to accept those plugins as donations to open source.
The next question is, does TOSCA include any application-specific standard support? For example, web gateway controls in scope?
Wow, I might have to fumble with an answer there because I'm not sure what that means. I think that one of the things I touched upon were domain-specific profiles. So in TOSCA, you can model anything. Our goal is to describe enough types in our base spec to describe cloud applications. In the network space, we describe virtual network functions, which includes things like routers and switches and gateways and things like that for that domain. You can model anything with TOSCA. If you want to publish it and as a profile, we can vote on it and at TOSCA and publish it as an OASIS standard. If there's certain aspects or certain domains you want to see modeled, even if it's a space station, there could be a space station profile of TOSCA that we actually publish. That would be kind of funny. I'd love to see it. So if you have a domain where you need to be, if you want to model something very particular, you can be very prescriptive and very precise and create very specific types for that domain. And that's what we want you to do. But you always use the same meta model, and we always continue to be compatible and leverage the types we have published already in the core spec.
Great, thanks. He says thank you. You answered what he was asking. Next question is, what other domains might we see additional profiles for?
Well, I'd love to see the container space work out. I'd love to, this Kubernetes, Docker, Rocket, container thing is kind of interesting, and it's a rapidly moving space, and so Docker itself and things like even doing things like profiles for how you integrate Ansible, because Ansible kind of in some places has the concept of roles, which is kind of like state. They transition, but they're not standardized. So I'd love to see more work profiling Ansible with TOSCA, one thing, because I know it's a very popular tool. I'd love to see more formalization of clusters and Kubernetes clusters, Docker clusters, but basically it's a moving target, and that's been one of our challenges in the container working group, is that Docker keeps changing, and they keep changing their Docker file and their descriptive language, their tags, how they do networking especially. Networking is the big stumbling block. And of course there are things like LXC and LXD that are available in Linux, which are often the workhorses of this, and that technology is evolving. So describing things when the technology is moving and the actual are changing month by month, it's hard for us to model. It really is. Because we don't want to cement a model that's changing and then it's out of date a week after we publish it. But I'd love to see those things. And our serverless technology, the new thing, Amazon Lambda, Google Cloud Functions, Azure renamed Cloud Functions, formerly Web Jobs. I'd love to see those things modeled. I think that an event-based models for serverless would be interesting to model.
Perfect. And that's it. It looks like we answered everyone's questions, and we're pretty close to the top of the hour. So we'll wrap up now. Thank you so much, Matt, for your time today, and everyone on the call for joining us. Again, I'll send an email out so you have a copy of the presentation, the updated presentation, and a link to the recording. And everyone on the call is welcome. If you're not already a member of the CSCC, we'd love to have you. When you sign up, we'll send you email updates so you can attend future events like this. And Matt, we'd love to have you back in the future. So everyone have a great day. Thanks.
Thanks.
Bye.